All right, assignment 7.6. You're given f of x equals e to the negative 4x, and you're asked to give a series that represent it. So we have 4 series we have to have memorized. Which one does this connect to? Obviously e to the x, and then we write it down. So that's 1 plus x squared, and so on. So show 4 terms. So I got 4 terms. And then instead of x, we have negative 4x. So it's going to be 1 plus negative 4x. And then negative 4x. And then negative 4x. So those are the 3 terms. Now the general term, which I know is tricky, it alternates right? Yeah. And there it is. Number 2. So a good first step is to know this is obviously connected to cosine. So I'm going to write cosine. What's the series that you need to have memorized? It's 1 minus x squared plus minus, and there's the pattern. Instead of x, put in 3x. And there it is. Now the nth term again. So 3x to the 2n, because that even exponent, and then 2n factorial, right? I know that's the toughest last step, but do you know this, memorize it, and can you substitute in to change it to what it needs to be? 3. So this is obviously connected to sine x, so I'll do that. So sine x is 1, no it's not, it's x minus, and it's the odd numbers. Alternating. So 2 things happening here. First of all, you're going to multiply everything times 2, and then replace x's with x squared. So this is going to be 2x squared, 2, and then x squared plus 2x squared minus 2x squared, and so on. Again, I'm going to help you with that nth term. And it's negative 1 to the n. It's alternating. It's 2, and it's x squared to the 2n plus 1 over 2n plus 1 factorial. Number 4. So this is connected to ln x. So I'm going to write down what ln x is. That's x minus 1 squared over 2. X minus 1, it alternates, make sure I do that, over 3. So there it is. So I'm going to multiply all of this times x minus 1. So x minus 1 times x minus 1. And then, so what it's going to do is to the exponent, right? And then the nth term I'll help you with. So it's x minus 1 to the n plus 1 over n. All right, number 5. We're going to work backwards here. And see if we can recognize which one it looks like. So it's alternating with this even. So this reminds me of, because it starts with x, then x cubed and so on, either sine or cosine. So if I factor out an x, I can make it match. So that means this is equal to x times cosine x. Number 6. Again, this is going to be either sine or cosine to work with, is it? Oh no. Oh, they got me on it. So do you notice it goes up by ones, like 2 factorial, 3 factorial, 4 factorial. So this is e to the x. So e to the x is 1 plus x plus x squared plus x to the 3 and so on. So if I did e to the negative x squared, it'd be negative x squared negative x squared negative x squared, and then look, so that's 1 minus x squared, that's x to the 4th and it's positive. This is going to be negative x to the 6th and it matches. So this is e to the negative x squared. Number 7. Looks like a logarithm, doesn't it? I'm going to write it out, the logarithm one. So ln x is x minus 1 minus x minus 1 squared over 2, x minus 1 cubed over 3, and so on. So when I compare, I can see that we're just multiplying it by 1 over x. So if you multiply this by 1 over x, 1 over x, 1 over x, it then matches. Number 8. Oh, this one's tricky. So let's say like you have 1 minus x squared plus and so on, and then you have x minus and so on. This is the power for cosine. and this is the power for sine. So that is cosine plus sine. Tricky, right, to look at. Number 9. Find the value of each of the following elementary ones. So first of all, which one does this look like in this form? And it looks like cosine. And therefore, what does x equal? If you follow this pattern, and you can see that x equals pi. Done. And if x equals pi, then cosine pi is equal to -1. Number 10. So e minus 1 squared over 2. This looks like a logarithm. If it was e, then it would have factorials on the bottom. So what's the ln again? What is the pattern? X minus 1 squared over 2, x minus 1 to the 3, so when you look at this pattern, then what does x equal? X equals e. So then ln e, and you have your answer. Number 11. So first of all, identify which series it looks like. And it looks like E, because they're all positive with this on the bottom. So let me write down what the E looks like. And then what must it be? So if I look here in terms of what x must be, 1 plus 4 is 5. And then 4 squared, 4 cubed, and so on. So x equals 4. So that means this whole series is e to the 4. Number 12. So if you look and see, it alternates and they're odd on the bottom. So let's see what sine x would give us. Oh, well, that's tricky. So for this to match, I kind of see that x should be 2, but I don't have a 2 in front. So if you put a 2 in front, then you can subtract a 2. Then this is sine 2, subtract 2. That is tricky. Number 13. Turn the page. Determine convergence. So some of these will be alternating. Some may not be. So the first thing I look at, if I plug in 1, if I plug in 2, if I plug in 3, and so on. So first of all, the absolute value is decreasing. Then the limit as n approaches infinity of this, it is more powerful on the bottom, so this is going to 0, so therefore it converges. It needs both the absolute value that's going down and it converges to 0, so it converges by the alternate series test. Number 14. So if I put in 0, if I put in 1, if I put in 3, I can see the bottom is more powerful, so it is decreasing. And then the limit as n approaches infinity. And you can see that the bottom is more powerful than the top, so this is here, so it does converge. And the reason is we say the alternating series test. Number 15. So already I know this diverges because the limit as n approaches infinity this is a 3, right? If you divide the power terms, it equals 1. And it has to, the limit must be equal to 0. 16. Here's another situation where the limit as n approaches infinity. Again, the top is more powerful. This is actually, so this diverges. It doesn't equal 0. Again, by the alternating, oh, this is actually the nth term test, right? This is the nth term test too. That it has to be to 0. 17. So if I do the limit as n approaches infinity here, this does not equal 0, so there it diverges, number 17. So cosine just goes positive to positive 1 and negative 1 as it goes to infinity. So this one does decrease to 0, the absolute value. And because the bottom is more powerful than the top, this just goes to 1 or negative 1, and in between, this goes to infinity. So as this goes to infinity, this stays between 1 and negative 1. Overall, this is going to 0. So this does converge by AST. 18. This is a geometric series. The ratio is 3/4. So this converges. And we can find the sum of it by going, plug in 1, it's 3/4, and then 1 minus 3/4. So this is 4/4. So this is 3. So 4 take away 3 is 1. Cross out the 4s. It's 3/1, which is 3. 19. So the limit as this goes to infinity equals 4/5. It does not equal 0, so it diverges by the nth term test. Number 20. So here the common ratio is pi. Pi is greater than 1, so it diverges by the geometric series test. That has to be less than 1. Oh, it's pi to the negative n. How tricky. So to write that, so pi to the negative n is really 1 over pi to the n. So really it's 1 over pi. So therefore it converges, because 1 over pi is less than 1. And the answer would be, if you plugged in 1, pi to the negative 1, so you'd have 2 over pi, make this pi over pi. So you have 2 over pi minus 1 is what it converges to. 21. This is alternating. Notice the bottom is more powerful than the top. So the limit of that is going to 0. And it decreases, so this converges. (22) Again, the bottom is more powerful, but if you look the base, so you multiply it by -2 and by 5, so it's really -2 over 5. The absolute value of that is less than 1, so this converges. So if I plug in 0, it's 1 over 5. So make this 5 over 5, so it's 7. So it's 1/7. 23. Which one does this match with? So it alternates with these even exponents. This is cosine. So if I took out the pi over 4 and put in x, this is exactly cosine. So x is equal to pi over 4. So it converges to cosine pi over 4. So it converges to √2 over 2. (24) So we have 1 minus 24 is a Taylor series. This is now a review question. All right, so the nth term would be negative 1 to the n. The numerator is 2 to the 2n because it's even. X minus 2, and again, it's even. So this is 2 squared and so on. And then over the odd numbers, which would be 2n minus 1 plus 1. All right, what's the center? That's at 2. So whatever this number is, if the center was 2, you go x minus 2. If the center is 1, it'd be x minus 1. What does f at 2 equal? And the answer is 1. Now, at this point, it might be helpful to write out what a regular Taylor series would look like. Let me go back. So, all right, so that's what it should look like. What I notice here is that we're missing the exponent 1. So that must mean that this value is 0. We got the 2, but I'm missing 3, so that means this value must be 0. So the ones that I'm missing, the answer must be 0, and that's why they're missing. So I'm missing f prime. So therefore the answer must be 0, because I don't see an x minus 2 to the 1. It's been skipped. So that means the answer is 0. The second derivative is there. So the form for the second derivative over 2 factorial is equal to this number, negative 4/3. So multiply both sides by 2. 2 factorial is 2, so multiply both sides by 2. And the second derivative of 2 then equals negative 8/3. The 11th one, that's what it is. So all the odd ones are 0, right? So the 11th one for 29 would be 0. I know, it's tough to see 11 compared to like the second derivative. That's 11. Number 30, 12 would be there. So it's 2 to the exponent 12 minus 12 factorial over 13. Number 31, what's the derivative of f at x? And you just take the derivative of what you see up here. So the derivative of 1 is 0. The derivative here is negative 8/3, x minus 1. The next one, when you multiply by 4, is 64/5. Subtract 1. And then 6 times 2 to the 6 divided by 7. And so on. Then 32, is the point 21 a local minimum, a maximum, or neither? So we have the point 21. The first derivative at 2 is 0, so that's good. That could be a turning point. And the second derivative is negative. So that means 2, 1 is a maximum. So concavity. So we know it's a turning point and it's negative. So the negative concavity means it's a turning point and it's a maximum. 33. It says write an expression for the nth term of these sequences. Assume n is 1, then 2, then 3, and then look what happens. So I see a factorial on the bottom, and then I only see 5 on top. So I see 5 over n factorial. So if I see it, yay. I know these are not easy sometimes. 1 over 4, 1 over 7, 1 over 10, 1 over 13. So I definitely see 1, but I see, like, what's this? It's just going up by 3, right? So this is actually like arithmetic in the denominator. I'll help you. The first term is 4, and then it's n minus 1. Sorry. The common difference is 3. Try it again. And then it's the first term is 4. If I multiply it out, that would be 3n plus 1. So if I plug in 1, it's 4, 2 is 7, and so on. Pretty good, right? Pretty nifty. 35. Determine if the sequences converge or diverge. So, what's happening here in 35? Right, the numerator, it goes 3, 3, 3. All right, so that's 3, n minus 1 plus 5. This is 3, 3, 3, n minus 1 plus 4. And then find it. So notice these just cross out. I mean, you get 5 over 4. It's pretty cool. It's done. Right? Did I do that right? No, can't do it that way. That was not nifty math. 3n, negative 3 plus 5, 3n, negative 3 plus 1. Power terms. So the power terms divide to 1, so it does converge, and it converges to 1. 36. Thank you. All right. You can say hi, Rebecca. Bye, Rebecca.
Bye. Have a good weekend.
Thank you. All right, 36. So the limit as this goes to infinity, you can see the top is more powerful than the bottom, so this diverges. It's actually not a series. It just diverges because it doesn't converge to a number. 37. 2 take away 2/3. And what am I multiplying every time? And it's negative 1/3. Subtract negative 1/3. So when you subtract a negative, it's plus. Six over 4, 3 over 2, and you have your answer. 38. Find a third degree Taylor for this. Centered at pi over 4. All right, here we go. So, f of x equals tangent x. It's centered there, so I need pi over 4. The value of tangent of pi over 4 is 1. Then the derivative. The at pi over 4. So it would be 2 over root 2. So it's the reciprocal of the x-coordinate. And if you square it, it's 4 over 2, which is 2. Oopsie, I need this. Number at 38. The third derivative, think of this as secant squared, is 2 secant, and then the hook, which is secant tangent. And then the third derivative, how many am I doing? I plead 3, right? Good. This is the last one I want to do. Pi over 4. So again, the value of pi over 4 is the reciprocal 2 over root 2 times 2 over root 2 times 1. So that give me 8 over 2, which equals 4. That's good enough for me. All right. And now what would this look like? So if we center it there, we start with this 1 plus 2 x minus pi over 4 over 1 factorial, if you like, plus 4 x minus pi over 4 to the 2 over 2 factorial, and then you would follow that pattern across. Done. 39. Find a series for the function f at x equals cosine x, centered at c equals 3 pi over 4. So again, we're going to do a Taylor. So f at x equals cosine x. So f at 3 pi over 4. That's here. There's 3 pi over 4. So the x-coordinate there is negative root 2 over 2. The derivative is sine, negative sine. So the derivative at 3 pi over 4, it's the y-coordinate, make it negative. The next one, the derivative of negative sine is negative cosine. So the second derivative at 3 pi over 4 is negative negative, the x-coordinate. And I'm going to do one more. It goes back to sine. Sorry, the next one's going to go back to cosine. So these are the 4, and then it goes back and rotates through. Of 3 pi over 4. So the y-coordinate is positive root 2 over 2. So the pattern is negative, negative, positive, positive, negative, negative, positive, positive as you go through. And then we're going to write a polynomial for this. So f at the first one is negative root 2 over 2 plus negative root 2 over 2 x minus 3 pi over 4 over 1, which I don't need, plus root 2 over 2 x minus 3 pi over 4 to the 2 over 2 factorial. Make sure I'm doing it right. The next one would be root 2 over 2 x minus 3 pi over 4 to the 3 over 3 factorial, and I'm good from there. And that's a Taylor polynomial centered at 3 pi over 4, knowing your unit circle. That's a good question right there. All right, number 40. Write the following function as a geometric series. So first, I'm going to write it as 1 subtract and then the first term, and then negative 2x to the n. And the convergence, divide by negative 2. So you go from negative a half to positive a half. I did it again. All right, that's number 40. Oh, I'm supposed to show 4 terms. So plug in 0, plug in 1, plug in 2, plug in 3. That's 8 and 3. It's 24. And so on. The general term here would be that 3 and negative 2x at the end. That's the general term. Number 41. Find a function for this series. So what am I multiplying every time? Am I multiplying negative 3/4 x every time? I am. So then the first term over 1 subtract that would be that. And then the interval of convergence. To undo this, you do first of all, it's a negative, so the arrow is going to change direction. And a negative times a negative is positive, and it's the reciprocal. So this would be 8 over 3. So negative 8 over 3 to positive 4 over 3, right? No, it's 1. So there. From there to there. All right, number 42. Give a series representation for these functions. Show four terms and a general term. So sine is x, it's really t, right? T minus t cubed plus t to the 5 minus t to the 7 and so on over t divide each term by t. So t divided by t is 1. That divides to t squared over 3 factorial, right? That divides to t to the 4th, so on. Now, integrate it, so that's t. And then plug in x. And it's done. 43. we're integrating write it as a series and then subtract 1 at the end. So the series is 1 subtract x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial and so on. And then subtract 1 divided by t. Notice 1 subtract 1, they're gone, and this should be a t. So 1 subtract 1 are gone. And then divide. So t squared divided by t leaves me with t over that. And then t to the 4th, that leaves me with t to the 3 over that. And then divide the t's, that's t to the 5th over that, and so on. Then when you integrate this, we add 1 to the exponent and divide. We add 1 to the exponent and divide. We add 1 to the exponent and divide. And that's from 0 to x. And then the last step is to plug in x. And you have it. All right, 44. Two left. Let's finish this. All right, these are called improper integrals. So I'm going to write this. You know what? I changed my mind. All right, I'm going to write this as the limit, obviously, as b goes to infinity from 0 to b. I'm going to keep it as this, and I'm going to write this as this. So e to the negative 1 over x. I think this is integration by parts. What the heck? All right. So we actually have two things going on here. So the 0 and the infinity. So 1, we want to know what's happening to 0 from the right. This is crazy. All right, I don't even want you to try it. I'm like looking at the answer. I'm going to tell you right now, the answer is 1. It's a good answer to have. I'm moving forward. I'm looking at it and going, I don't want you to like completely go in the wrong direction here and destroy your confidence. I'm not going to let my confidence be destroyed. I can do this one. So I'm going to factor it. And then we're going to have a and b. So we have a with x minus 3. We have b with x plus 2. And that should equal x minus 28. So a is going to go with x plus 2. B is going to go with x minus 3. So I'm going to use negative 2. If I plug in negative 2, I get negative 5b and negative 30. So b is 6. I'm also going to use positive 3. That's 5a. And negative 25. 3 take away 28. That's a is equal to negative 5. All right, so we have a being negative 5. We have b being positive 6. And now I'm going to integrate them. Kind of ran out of space. Let's see if I can still make it work. So it's negative 5 ln x minus 3 and 6 ln x plus 2 from 0 to 3. Is that right? Oh no. Are you kidding me? Do you know what I did wrong? So notice that 3 is improper because it makes it undefined. So I need to set it up not only with a and b, but also as a limit as it approaches it, and so on. Well, that's the bell. That means I'm just going to give you the answer. This whole thing diverges because of it. I'm done. You're welcome by not going through the page that's looking at the answer key. Mr. G Math over and out. Till next time. I'm so proud of you for finishing your work.